Good evening, class. We are looking at section 6.3, and this is being recorded. We covered the first section, area between curves, the second one, volume, the method of disk, and now we're going to go with the cylindrical shell. We need to be comfortable with basic integration formulas. The first section, the area of the region between two curves. Basically, you need to remember dA is HDH. That is a typical vertical or horizontal strip. And then you got to find the H and DH, and you are fine. We looked at the method of disk. dV is pi r squared dH. dV is pi r squared dH. Okay, what I'm interested for everybody to remember and to know is this. If you stick with this class, all you have to do, figure out the R and DH. DH is always dx or dy, that's all. And then if it happens, this is the method of disk. If we happen to use a washer, then it becomes R out squared minus R in squared. We want to go to the new section. So we're going to stick with the method of this to just refresh your memory as to what happens and how we deal with that, okay? And let's look at this example, and we want to the region is y equals x squared plus 1, okay? And it's between that and x equals to basically the shaded region, okay? And we want to go around the y-axis, okay? Around the y-axis. So what's happening here is there are really two parts. The bottom part, okay, because if we want to go around the y-axis, the idea is ultimately becomes like this. Up to here, class, you really are looking at a cylindrical shape, okay? But the top from here, things change. So you have two parts, the bottom part and the top part. Method of disk. By the way, obviously when you draw this, that means dy, okay, class? So y equals x squared plus 1. So you take the 1 to the other side and becomes y minus 1, and x becomes square root of y minus 1, okay? So we're going to split this into two parts. This part, okay? Here's the outer piece, which is what? All of them, the outer piece, R out is equals to 2. Here's the inner piece, R in is the x coordinate. So first, understand these are x coordinates, class. So x coordinate of this part, okay, versus x coordinate of this part, okay? So the x coordinate of the outer piece, okay, is 2 units away from the y-axis. And for this piece, you use the curve. So I'm looking at this top piece. I'm looking at, let me use a different color. I'm looking at this part, class. just the top part for now. Okay. So the outer piece, R out, it's always 2. And R in is the x coordinate of the curve or the parabola, which is square root of y minus 1. So in other words, this is R in, R out equals 2. And we are using this one. So R out, let me just make sure I put it in the right place, because you know when I write, I don't want to. So let me put it in this corner. R out is 2. R in is the x coordinate of the curve square root of y minus 1. dh is dy. And over here, it's 1. So this will go from 1 to 5, everybody. That's why, let me erase this part so everybody can see. We are going to go from 1 to 5. I'm just looking at this portion, okay? But the bottom portion is just the cylindrical shape, okay? Pi r squared h. The bottom part, everybody, is just the cylindrical shape, pi r squared h. Pi r squared h. What is r? 2. So this part is just pi r squared h. What is r? 2. What is h? 1. Okay, there's not much to that. Now the rest becomes history. We can simplify and evaluate. I'm assuming everybody can do that. Okay, so take a look. So here's the outer radius, here's the inner radius, and here's the thickness of slice. Here's the cylinder as it was mentioned. If we simplify this one, class, we get 4 minus y minus, which becomes 5 minus y. Now, this one is 5y, this one is minus 1/2 y squared from 1 to 5, and don't forget the pi in front of it. And it's 4 pi because pi times 2 squared times 1 is 4 pi. You finish the job by plugging in 5 and 1. I'm assuming everybody can do that. So this becomes 25. This becomes 25 over 2. When you plug in 1, you get 5 minus 1/2. And all of them are multiplied by 5. Simplify this one, add 4 pi. So I'm assuming everybody can do that, class. So I wouldn't worry about that. What is interesting, class, this is the method of disk. And for a case like this, works fine. You cut it into 2 parts, okay? And by the way, one part becomes a disk, part becomes a washer, okay? It's a washer that we did. In other words, if I were to draw this, it would look like a washer, okay? Now, we can use a different method for a case like this when we are going around the y-axis, and we use what's called the cylindrical shell method. So let's see how that works. The typical formula that you see at the bottom here is using 2 pi x f of x, but again, I'm going to show you what I'm going to use in a moment, okay? I rather go with a 2 dv and I'm going to write it for you. I rather go with dv, again it's 2 pi r h dr. This always go back to the choice of r, everybody, okay? But I'll explain what that means in a moment. Okay, so in this method we use a shell. That means we are going to look at the lateral surface area of a cylinder. First, I want to make sure everybody understands what that means. When you and I'm going to erase that in a moment. If you happen to have a cylinder class, okay, you want to find the surface area is the pi r squared, the base, times 2, okay? So this one would be, so the surface area would be pi r squared times 2 plus the lateral area, which is 2 pi r, which is what? The circumference of the base times the height. So I hope you see, everybody remembers 2 pi r h, right? Now, if you want to find the volume using the method of shell, you can think about this cylindrical shape and peeling off a very, very slim part of this. And by the way, this lateral area can be opened up as follows. This is H, this is R. So this is still H, but this is what? 2 pi R. So if you cut a very, very thin slice, then it has a thickness. And that thickness we're going to call dr, which multiplied by this part, if you multiply it by this part, it creates a volume for that thin piece. Add them up, and it becomes the volume. Let's explain that with a little bit more details. I need to erase this for you, class, because we need the page. Okay, so take a vertical slice, revolve it about the y-axis. Look. Okay, so pick a vertical slice and revolve it about the y-axis. It creates a hollow cylindrical shape. Okay. Now imagine you pick another vertical slice. It creates another hollow cylindrical shape, so on and so forth. So if you do it infinitely many times and add them up, it becomes there the volume. Okay, so add all of the cylinders to reconstruct the original object. The lateral surface area of cylinder times thickness, okay, would be dV. So we have 2 pi r h times the thickness. And the thickness, class, I like to call it dr. Depends really on r. R becomes either a function of x or a function of y. If r becomes a function of x, then this becomes dx. If r becomes a function of y, this becomes dy. Okay, so let's see if we can figure this out. You're looking at this one, right? This typical cylindrical shape, okay? So we're going to stick with that, 2 pi RH. We are going around the y-axis. So I hope you see that. If you pick up a point and call it XY, class, pick up a point here as coordinates XY. I hope you realize the X is the R, and the y is the height. Okay. So replace the r with x, replace the height with the function, which is y equals x squared plus 1, and because r is a function of x, thickness becomes dx. So take a look. That's the r. This is the circumference, and this is the height. And now times the thickness gives you a volume of this thin, hollow, cylindrical shape. Take an integral. That's all you have to do, class. Now this gives you x cubed plus x. This gives you 2 pi times 1/4 x to the power of 4 plus 1/2 x. Evaluation from 0 to 2. That gives you 2 pi times 4 plus 2, which is 6. Notice the answer of 12 pi, everybody. I believe we arrived at it a lot easier and faster. I hope you realize that and you agree with me. If you compare this to the previous one, in one shot, we have the answer. This is the method of shell, everybody. So let's quickly recap. And let's look at a few examples. Here's the recap. This is called the shell because we use cylindrical shells. So here's the recap, everybody. Volume of a solid shell method. The volume of a solid rotated about the y-axis, okay, uses this formula. Okay, this is the formula that is used by the text, 2 pi x f of x dx. Okay, 2 pi x is the circumference, f of x is the height, dx is the thickness, this is a dv. And definition of a volume of a solid of shell, the volume of a solid rotated about the x-axis uses this formula. And because I want to combine all of this and I want to make some sense out of this, I really want to go with 2 pi r h dr. All you have to do, find r and h and you're done. By the way, dr always goes back to r, meaning a function of x or y. And again, what we did, remember, if you open this up, looks like that. And this is 2 pi x and this is f of x. So you can stick with the formulas there, or this is a general formula. I think it makes it easier. We'll see. You decide what works for you the best. All right. We have the region. Okay, so take a look at all of this. They happen fairly fast. Look at what happens. We have the region that is bounded by this function and the x-axis. That means this region. And we want to go around the y-axis. So if you pick a typical vertical strip and revolve it about y-axis, it creates this hollow cylindrical shape. It looks like that if you, expand it. That's the idea. We are going to use dv equals 2 pi r h dr, and the volume is the integral of a to b dv. Okay, so we need to find the radius and the height. The radius is clearly the x, everybody. So we're going to replace the radius with x. The height is clearly the y. We're going to replace it with f of x, which is this function. And we need a and b. We're going to go from here, having x coordinate 2, all the way to here, having x coordinate 8, from 2 to 8. That's it. So x is R, y is h, a and b are 2 and 8. So R is x, h is y, here's the function, dr is dx, and here's those numbers 2 and 8. And by the way, the graph gives you 2 and 8. But if you don't have a graph and you want to figure it out, you have to set this function equal to 0 to come up with those two numbers, class. You need to set it equal to 0 and solve to come up with the x-intercepts. The reason you do, because you want to know the limits of a and b. So this part, as you can see, it's basic algebra, okay? You can factor this part easily, and we have 2 pi x times the function. Again, I'm going to leave this for you to finish it. I'm going to assume you can do that, okay? You're going to multiply the x here, we get x cubed, and gives you, so if you want to, you can write this as, let me just put this out. 2 pi and negative 4 over 9 is 8 pi over 9. 2 times 8. And the x gives us x cubed minus 10x squared plus 16x dx minus 8 pi over 9 remains. This one gives us 1/4 x to the power of 4 minus 10 cubed plus 16 halves x squared. Okay. And you just got to plug in 8 and 2. It does take a little bit of time. I leave it for you to finish it. I hope you realize it's not too bad and it is doable, everybody. So from here to here takes a couple of steps. You can come up with the x. Here's the next one. We want to find the volume of the solid obtained by rotating the function y equals 2x squared minus x cubed about the y-axis, okay? So the region is bounded by this function, everybody. And the x-axis, when we say y equals 0, that means the x-axis. So this is the region. Again, pick up a typical strip and revolve it about the y-axis, and it gives you a hollow shell, if you will, a cylindrical shell. And we are going to use 2 pi r h dr. So clearly, this is r, this is h. So r is x and h is y, or 2x squared minus x cubed. So replace. Replace r with x, replace h with y, or f of x, which is 2x squared minus x cubed. Therefore, the r clearly is dx. Clearly is dx. And this is what we have. Now, obviously, we have to, and again, we have different colors to make some sense out of it. We have to multiply x by this expression. The 2 pi in or out, it doesn't matter. It just remains as a constant. 2x cubed, this becomes 2 over 4, x to the power of 4. Okay. And minus 1/5 x to the power of 5. It's 1/2, everybody, okay? 2 over 4. So you want to make sure. Okay, so this is fixed now. And plug in 2, you get an answer. 0 gives you 0, and therefore the final answer becomes 16 pi over 5. Okay, everybody? If you plug in 2, 2 to the power of 4 is 16. 16 divided by 2 is 8. 2 to the power of 5 is 32 minus 32 over 5. Okay, can take a common denominator of 5, do the math, and multiply by 2 pi. And that's your final answer. It's pretty straightforward, everybody. We want to find the volume of a solid obtained by rotating about the y-axis. Okay. The area under this function, we should be able, this is a simple function, x squared is parabola, and y squared plus 1 shifted up by 1 unit. We want to go from 0 to 6. So you have parabola that you have shifted up by 1 unit. And this parabola class, this is 0, 1. This point is 0, 1. Maybe this point has coordinates 0, 1. Okay, everybody? Coordinates 0, 1. And you are revolving this about the y-axis. Look at the shape. It's very straightforward, right? If you pick the whole thing is done. If you pick a typical strip and do that, it gives you that, okay, class? And dV is 2 pi r h dr. As you can see, the r is the x coordinate and h is the y coordinate. So here's the x, r equals x. Here's the h equals y or f of x. So r is x, h is f of x. F of x happens to be x squared plus 1, and therefore the r becomes dx. And you write the formula 2 pi x times x squared plus 1 dx. This repeats. It's a simple case. You can easily finish it. So put the x in, becomes x cubed. Two pi remains, x cubed 1/4, x to the power of 4, this gives you 1/2 x squared, and you are evaluating from 0 to 6, by the way, because it said so, okay? Now you plug in 6, and you plug in 0 gives you 0. So you plug in 6, this is the power of 4 over 4, and this is 6 squared over 2, and simplification will result in 684 pi. 684 pi, okay? Let's look at one more example, class. We are looking at the method of shell. We want to find the volume of revolution formed by rotating y equals x squared. Okay. Around the y-axis, it's between y equals x squared, y equals 0, and x equals 1. Okay. Well, as you can see, the typical revolution has happened. Here's the R, here's the H, or if you go all the way to the end, here's the R, here's the H. R is clearly the X coordinate and H is the Y coordinate. So R equals X and Y equals f of X. That's, I think, pretty obvious. So let's plug in. dV is 2 pi r h dr. We are going to replace the r with x. So this is the radius. This is the height. We're going to replace the h with y or f of x. F of x happened to be x squared. Therefore, the r becomes the x. Now plug in from a to b. We're going to go from 0 to 1. So this is 2 pi x cubed, and therefore is 2 pi divided by 4 x to the power of 4. Okay, so 2 pi times 1/4 x to the power of 4. From 0, 1 to 1, if you plug in 1, you get 1/4. 0 gives you 0, so 1/4 times 2 pi, the answer is pi over 2. Now, same question, class. It's a good practice to see the method of disk in case how that works, okay, just for the sake of argument. And the point of this question is, again, to remind you, both methods do work. Sometimes one is a lot easier than the other one. So take a look at the method of disk. The method of disk says, okay, first of all, that's the same thing, okay. The method of disk says, here's what we need, okay. Now this is going around, so we, instead of a cylindrical shell, we go with the disk, and this creates the hollow disk, which we call it a washer, okay, and we have the R out from here to here, and R in from here to here. I hope you realize that. Okay, so this is the disk, and this is R out, everybody. And this is R in. So the red one is R out, the blue one is R in, and I'm reminding you of this formula. So the R out is from here to here, which is fixed at 1. The R in from here to here, which is the x coordinate of this function, this curve y equals x squared. Okay, x squared is cut off, class, here. So let me actually put that for you. So this is x squared. All right. So going with that, R out is replaced with 1, R in is replaced with the x coordinate. So if y equals x squared, x is square root of y. So we are going to do this. And what is dh? We get the disk, we're going to go up and down. So dy. So let's replace everything accordingly. So pi, 1 squared minus square root of y quantity squared. So this is R out, this is R in dy. Why are we going from 0 to 1? Believe it or not, this goes from 0 to 1 here, goes to 1 here also, because this point has coordinates 1, 1. So along the y-axis also it goes from 0 to 1. It just so happened, I want you to know, for the sake of argument, if we were going from 0 to 2, then it will go from 0 to 4, okay? So it just because it's 0, 1, 1 squared is 1, so that's why the y coordinate ends up being the same. We are not using the same 0, 1 here, okay? We are using from here to here, it so happened to be 1. And now we simplify this to 1 and this one to y, so pi remains. 1 simply gives you y, and minus y gives you minus 1/2 y squared. And if you plug in 1, you get 1 minus 1/2, which is 1/2, and 0 just doesn't do you any good, gives you 0. So it gives you the same answer, pi over 2. The purpose of this question is to show you both methods work, class. They do work, but I hope you realize the method of shell was easier in this exam.